So my name is Robert Aboukhalil, and I work at Cold Spring Harbor Laboratory back in New York. And so my work consists of building data analysis tools to be able to make sense of large biological data sets. And so the goal of today is really to guide you through.
Did you ever get a room monitor?
Sorry?
Did you ever get a room monitor? Oh, hey, sorry, okay.
Yeah. Yeah, so the goal today is to guide you through building a web app that does the following. So we're going to start with asking the user. So we're going to ask the user to input a set of coordinates in 2 dimensions, and we're going to build an app that will cluster these data points on the back end. It's going to report the progress to the user as it's clustering. And once it's done, it's going to allow the user to actually visualize and explore the data. And so we'll start with the basics of why are we actually building these web apps, why it's important. And then I'll guide you through how to do basic backend data analysis, launch analyses with PHP. Then we'll talk about how to use Bootstrap and jQuery to look at the progress and talk about visualization. Okay, so let's get started with the basics. So instead of telling you why we need web apps for data analysis, I think I'll just show you. So a few days ago, I was looking at the software package that analyzes some biological data to look at differences in DNA. It doesn't really matter what it does, but here's my experience trying to install it. So I opened the browser, navigated to the web page, got the download link, and went to the command line, did wget with a zip file, downloaded it. Once it was done, I unzipped it, went into the folder, and of course, first thing you do is you look at the README file. As it turns out, you can't just install it, you need to install another package before that because it has dependencies. So okay, you go back to the browser, look for this package called root. It has nothing to do with root users. And you get to the website. There's a big download button, so you click on it. Okay, so the latest version is root version 6, so you try to install that. And you get the URL and you go back to the command line. Now you download this, and of course this file is pretty huge, so it takes quite a bit of time. But once it's done, you can untar it and move into the folder. And if you go back to the website and they tell you how to actually install this, they just say run configure, and it will work. Right, so you go back to the command line, type configure. Unfortunately, it doesn't work. It gives us an error. C++ 11 mode is requested, but current compiler does not support it. Okay, we go back to Google, look for ways on how to fix this issue. After banging my head around against the wall for a bit, I just decided to go back to the website and download an older version of root, because why not? And so when I did that, let's go back up, download the older version of root. Again, it's a pretty huge file, so it's going to take a while. But once it's done, we can actually untar it again, move into the folder, type configure again. This time, we get a different error. Right, so now it tells us to go see another URL. So we go back to the browser. As it turns out, our dependency has about 12 other dependencies. So we go back to the command line, try to install them using yum install. Fortunately, you need to be root to do this command, and I don't have root access on this box. So okay, back to the browser, look at ways of how to do yum install without being root. And finally, I came across this page that tells me that actually there's a command called yum downloader that will do the same thing. It will download the package. And once it's done, obviously what you have to do is type rpm to cpio and pipe it to cpio-ip, which makes total sense, right? Then when you press enter, you get the really useful output of 119 lines. So I'll spare you some of the details, but basically I had to do the same thing for all these dependencies. And once you do that, you type configure again, and it still gives you the same error. Because it turns out you have to tell it where the subdependencies were located. So you do that, and then it actually starts working. And then it tells you now you just need to type make, and everything should be fine. And you type make, and it seems to be doing really well. There's a lot of stuff that's output to the screen. And after a few minutes, we get another error. Error number 1. As it happens, what you have to do to fix this error is open this file and go to line 31 to 36 and just do a few little things here. Don't mind me. And then I exit, and then I keep doing make, and it'll keep working. And things look really good, except when I get another error 1, but this time on another file, so I have to edit the root xx.cxx file. Very, very intuitive. When we go to line 22, add this little bit of code and rerun make, and then magically it works. Now it tells us to run this little bit of code here, so we do it. I'm not sure what this does, but why not? So now we've installed one dependency. There are other dependencies, so I just need to go back up, type these 2 lines. I'm not quite sure what they do, but if you don't do that, nothing else is going to work after that. So anyway, you go back to the second dependency and you make it, and as it turns out, this one is really easy. So then you go back to the top folder and you install the whole program. And finally, it works. After hours of banging your head against the wall. And so the point of this is that this was a relatively easy installation. We only had 2 dependencies. Of course, one of them had 12 other dependencies, but that's besides the point. And the problem is that the vast majority of your users won't do that. Especially in my field where our users are biologists and doctors, they're not going to go on the command line ever. And so, why web apps for data analysis? Basically, installing software packages can be a nightmare. If you want the users to use your software, it has to be usable. And the nice thing about doing it on the web is that you allow your user to access it from anywhere. Okay. Now I just want to show you an example of the kinds of web apps that you can build using what I'm going to teach you today. And so this is a software that we recently developed called Ginkgo, and to explain what it does, I just need to tell you a very little bit of biology. So basically, in all our body, we're made of trillions of cells, and each cell contains DNA, and if you look at the DNA all over the body, it's pretty much the same for one individual. But if you look at a sample like a tumor compared to a normal tissue, you'll see a lot of differences. And so typically when you want to study a tumor at the DNA level, what people will do is that they'll take the whole sample and treat it as one homogeneous thing. When in fact there are different regions of the tumor that are going to be very different. And so what this program allows you to do is essentially analyze this so-called single cell data. And let me just show you the kind of things you can do there. So basically this is Ginkgo, and what it does, it allows you to upload some data that you got after you did this experiment. And what it allows you to do is after you upload these data sets, you can tell the app what the parameters of the analysis is. So I won't go into too much detail, but basically you can specify all your parameters, and you can enter your email if you want to be notified once the analysis is done. And then once you do that, you can click Start Analysis. And so this kind of stuff where we show the user the progress of the analysis, we'll show you how to do that. And let's just fast forward, because this kind of analysis can take hours. And once the analysis is done, you can do really interactive stuff like show a tree where all the leaves indicate individual cells, and we can allow users to actually click on each cell and really navigate through the profile of that cell. That's just a quick overview of what you can do. So now let's actually get started by doing a very basic backend data analysis tool. So here's what we want to build. We want to build a really simple tool where you just specify 2 numbers in the URL and you add them up together. Now, of course, you could say, well, I can just do this in one line. Why are we doing this? You just have to imagine that for now, the analysis that we're doing is not as simple as adding. We're going to do something a little more complicated later, like clustering points in 2 dimensions, where PHP is not really suited for doing that. And so for now, let's assume that we have a program called add, which is a shell script that sits on the server, and it's going to do this, supposedly complex analysis. And so we can replace this echo with this function in PHP called shell exec. And what shell exec does is it will execute the command add.sh with the 2 parameters, and it will output the result. And add.sh is simply a bash script that will just add up 2 numbers and output it to the screen. And so now the idea is that you can actually make this add.sh script as complex as you want to. You can call other scripts that do other kinds of analyses. And so if you just run this, it'll give you, basic output. If you type n1 equals 5 and n2 equals 4, it'll give you 9. If you say n2 equals minus 4, it'll give you 1. And so there isn't only shell exec to do these kinds of executions on the back end. So I just want to go through a few functions in PHP that are really useful for this. So if you want to execute a command and return the whole output as 1 string, shell exec will do that for you. If, however, you want to output the output to the screen while it's running and return all the output as a string, you can use the system command. And so the first argument of the system command is the command you're running, and the second argument is the name of the variable that will contain the return code once the system finishes executing. So that allows you to actually check what is the return code of that program, in case you're interested. Another thing you could do that's really useful is what if you wanted each line of the output to be stored as an index in an array? You could use the exec function. So the first argument is the command line that you want to execute. The second is the name of the variable in which the array is going to be stored once you execute the exec command, as well as the return code. Another really interesting thing is what if you wanted to have a command line analysis on an image or any binary format and output that binary format to the browser. So typically what you would do is you set the header to a type image, and then you just output the whole contents of the image to show the binary. But what if you had a command line that allowed you to do something on the image, like resize it or draw on it, and you wanted to directly output the output of that command to the browser? There's this very useful command called pass-through. And so the first argument of pass-through is the command that you want to execute. For example, if you have a script that will resize a PNG image, and the output of that is directly output as binary to the browser. And so this allows you to skip a step, right? So you don't have to save the output of resize to another file and then output that to the screen. Okay. So these typically work well when you're doing analysis that's pretty fast and you want to get the result right away. But what if we're doing something like clustering data points where it's going to take a little bit of time and you don't want PHP sitting there waiting for the result to come back? So if you want to run programs in the background, what you can do is, just like you would do when you're on the command line, you can add an ampersand at the end of the command, and it's going to run in the background. However, in my experience, if you're using a CentOS box, this doesn't usually work, and you'll have to use a different approach, where there are two functions in PHP that help you do this. It's called popen and pclose. And they're essentially equivalent in their syntax to like the others we've seen before. But basically, you open a process and you specify the command that you want to run, and you can read to that process, and then you close it. And now the analysis script is running on the server, and the PHP can continue running the rest of the code. So I just want to go back to this example and show you a little something a little scary. So if you add up 5 and 4, it gives you 9. If you add up 5 minus 4, it gives you 1. You know, we're just playing around with it. Why don't we add letters there? Okay, interesting. It doesn't give you an error. It assumes A is a 0. What if we set n2 to be 4, semicolon, echo hello? This actually allows us to execute arbitrary commands on the server, which you don't want to happen. And you can even browse through the server's file system as much as you want. And depending on the permissions that your server has, you might actually be able to delete important files. So it's why it's really important that whenever you're doing analysis tools that have access to the server, you really need to sanitize the user's input. And there are 2 functions in PHP that do that. One is to escape the actual arguments that your user provides to you using escape shell arg, as well as escaping the whole command that you're sent using escape shell cmd. And so escape shell cmd will actually escape characters like semicolons, ampersands, asterisks. So those are extremely useful, and you always have to think about these when you're doing data analysis on the server. Yeah. Yeah. So it's actually on my website. Oh yeah, it's right there. Aboukhalil.com/talks. Okay, so now we've built a really basic analysis tool that basically takes the user input, launches the program on the server. Now we want to actually show the progress of that analysis. And so here's, what we imagine one is we just want a page called progress that shows you, how far along are we in whatever calculation we're doing. So we'll start out by defining a script called launch. And all that launch does is it'll launch a command line program called app.sh in the background. And then app.sh is simply a loop in bash that loops from 1 to 100. And each time it loops, it will output the current value of I to a file called progress.txt. And then it will sleep for 2 seconds. And so basically every second you'll increase progress, and now this is running in the background, and progress.txt is updated every 2 seconds. Now we want to actually show this to the user, so we can write a status.html file. And we start out by just including what we'll need, so we're going to use Bootstrap to do nice looking progress bars. We're going to use jQuery to contact the server and get the current progress. So the way we do this is first we find what the progress bar is. And if you're familiar with Bootstrap, there's basically the progress class and the progress-bar class that allows you to very easily build progress bars. And all you need to do to make them change is change the width of progress-bar. Okay? And so now we're going to write some JavaScript to actually do that, where we'll start by writing a function called getStatus. In getStatus, we'll use jQuery to contact the server and get the value of progress.txt, right, which contains a number from 1 to 100. Once we get the answer from the server, we're going to run a function on whatever data the server gives us back. So in this case, I call it progress. And we're going to update the div that's called analysis-progress. And we're going to update its width to match whatever's in the text file. Okay, so now we have this function. And each time you call that function, it'll change the width of the progress bar to whatever progress we're at. And we can run this, let's say, every second or so. And so now basically we're polling every second on the server to check how far along the analysis is. And we're updating the progress bar as it happens. So of course, there's a little problem here because we keep polling all the time, and that's just because fundamentally, HTTP is a stateless protocol. It's not really meant to do things that, it's not meant to build connections that are sustained between the client and the server. So I'm not going to talk about it today, but there is, yeah, this is what the progress bar looks like. So there is an alternative to polling called WebSockets, where basically you're able to set up a two-way connection between the server and the browser. And instead of sending HTTP packets all the time, you can send an HTTP handshake, and after that, you just do WebSocket package, and it's much more efficient, and you don't have to keep polling all the time. But anyway, if you're interested, I'm giving a talk today at 2 p.m. about how to use WebSocket with Node. It's basically the same thing with PHP, it's just a matter of implementation. Okay, so now we've built an app that does analysis on the backend. We can now show progress to the user. Now let's build this clustering app and do every step that we've done and actually show the results to the user. So again, what we're anticipating is we want to let the user input a set of two-dimensional coordinates, and we want to somehow run an analysis on the back end that is going to cluster them and color them on the client. That's illustrated. So the first thing we need is a launch.php code. And what this will do is basically let's define a form that asks the user for x and y coordinates, and we'll put in a text area. And basically what we want the user to do is enter XY coordinates on each line. Basically just like a CSV file. And then once the user clicks the cluster button, we want to run a command on the server that's going to do this clustering. So in this case I'm using a language called R. How many of you are familiar with R? Okay, so basically it's a very useful tool in data science. If you want to do any kind of statistical analysis, R is one of the most important ones, along with Python. And so essentially I'm executing this command which will run the script cluster.r. For now, just imagine that it'll magically cluster our data. And we'll give it the argument that the user gives us, which is basically a list of x and y coordinates. And we'll run it in the background. And then we'll do p open and p close. So now this is what it looks like when the user clicks cluster. The R script is going to be running on the server. Now let's look at this R script. So one issue is that R is a pretty odd language, so I'm not going to go through all the details of it. But I'm just going to guide you through what the program looks like. And essentially, we're going to include a library in R that allows us to do this kind of clustering. And the approach we're going to use is called Gaussian mixture models, where we're going to try to fit our data to a weighted sum of Gaussian distributions. And the way we're going to find out what the best clustering is that we're going to try to cluster our data in 2 clusters, and then 3 clusters, and then 4 and 5, all the way up to 20, and see which one of these clustering schemes gives us the best result. And one way to evaluate that is to just ask, look at all the points in one cluster. Are they more close to each other than they are far away from the rest of the data points? And so anyway, this library allows us to do that. And then we'll parse the input that the user gives us. And all this does is write into data a matrix, and you basically have the x and y coordinates as columns, and all the rows are the number of coordinates, the number of data points. So then we'll use this clustering algorithm, and like I said, we're going to try to cluster it from 2 to 20. And each time we do this, we're going to call the function that allows us to do the clustering using the set number of clusters. And each step, we're going to increase the percent progress by 5%. And we're going to output, again, to progress.txt, what is the current progress of our analysis. And then we just need to manipulate the data a little bit to figure out what is the best clustering scheme, and then we output the result to result.txt, and that will just tell us in which cluster is each point contained. Okay? So now we've clicked on the cluster button. The cluster.r script is running on the server. Now we want to show the user what the status is. So again, we do the same thing. We load in jQuery, Bootstrap. We define the progress bar. We use a script to basically update the progress every second by querying progress.txt. And it will look something like this. So now we want to actually visualize the output. We want to show the data points and color them differently based on the clusters they belong to. There's probably hundreds of JavaScript charting libraries, but I'm going to just focus on this one called digraphs, which is one I like pretty well because it tends to be really fast when you're dealing with a lot of data. And so the way we want to output our results is like as follows. So we have a file now called visualize.html, and we're going to load in our JavaScript library. We're going to define where this graph is going to be plotted, and we're going to use some JavaScript to plot the graph. The way digraph works is that you can, the first argument that you give it is which div the graph will be contained in. Second argument is the file that contains the results. Right? So in our case, it's basically telling us in which cluster each data point is located. And then we have a few settings where we're basically telling it, don't draw lines connecting each point, because we just want a scatter plot here. We define the point size to be 5, and we want the points to be 1. So then, what it basically looks like, this is a plot of the data points that I entered before doing the clustering, and after the clustering is done, it basically does this. Okay. So now we've basically gone through all the steps building a data analysis app, shown how to take input from the user, send it off to a command on the server, and while it's running, you can fetch the current progress. And once you're done, you can show the output like this to the user. And although this is just an image, in reality, you can actually hover over these points, and you'll see information about their x and y coordinate. You could even expand this to let the user click on each point and access another page that gives you more information about that particular point. Right? You can do tons of other things. And as in summary, if you want to run commands in the background, basically use the ampersand, use shell exec, the close, the open. It's extremely important to sanitize the user's input using escape shell arg and escape shell cmd. Bootstrap allows you to make good-looking progress bars by just changing the width of the div. And there are many JavaScript charting libraries. Check out digraphs, it's pretty good. And if you're interested in learning more about data analysis and doing more of this kinds of analyses, R is a really good tool for that. So that's all I have for today. Thank you for coming.
So I've been playing with a lot of different charting libraries, especially D3 and I think ChartUV and such was like tier of D3. Is there a reason you chose digraphs over D3?
So I actually think digraphs is based on D3.
Okay.
Like almost.
It's the first time I've heard of it.
But so they have this really nice feature that I use a lot, which is that if you have a really large data set and you want to visualize it, you can show a very rough version of the data at first, and when the user zooms into a region, it allows you to go into Backend and download more data that's more specifically shows what happened in the region. So these kinds of features seemed pretty useful, at least to me, and it seems pretty fast. Any other questions? Yep.
How'd you get that domain? It wasn't taken?
Not quite, no. Tried for robert.com.
Yeah. That one was taken?
Yeah.
How do you say that last name?
I'm sorry?
How do you say your last name?
Lulu?
Luca.